In just 24 hours, the clock runs out. Tomorrow, December 19th, is the moment we have been waiting for. The interstellar object 3I Atlas is about to make its closest approach to Earth, swinging by at a distance of 1.8 astronomical units, roughly 269 million kilometers. This video is your rapid-fire guide. We are cutting through the noise. We aren't looking back at how it was found, we are looking at the now. We are breaking down the live data streaming in from Hubble and the ALMA observatory. And I have to be honest with you, the data isn't just strange, it is beautifully, terrifyingly impossible. Let's start with the visual evidence. Hubble has just taken a new look at 3I Atlas as it retreats from the Sun. By all laws of astronomy, a comet moving away from the heat should have a tail trailing behind it pushed by the solar wind. But Atlas is defying the rules. Hubble has confirmed a sharp, stabilized anti-tail. In standard textbooks, an anti-tail is an optical illusion, a trick of perspective. But this structure is persistent. It is a physical spike of material pointed directly at the Sun, locking onto the star it just survived. Avi Loeb points out that this needle remains fixed on the Sun regardless of the object's rotation. Think about that. A tail that fights the solar wind, or is it a stabilizer? We are seeing two distinct jets. One is the messy cloud we expect, but the other is a precise sunward lance. It looks less like a crumbling rock and more like a focused exhaust plume. But the visuals are nothing compared to the chemistry. The ALMA telescope array in Chile has been sniffing the coma, and the results are shocking. We are seeing massive spikes of methanol and hydrogen cyanide. Don't let the word cyanide scare you in space. These are the Lego blocks of life. They are the precursors to amino acids and DNA. The smoking gun here isn't that they exist, but the ratio. We are measuring 124 parts methanol to 1 part hydrogen cyanide. This is off the charts. We have almost never seen a cocktail mix like this in a natural solar system comet. This forces us to ask, is 3I Atlas a serial killer dumping poison or a friendly gardener? Imagine a farmer walking a barren field throwing seeds. Is this object a natural carrier of panspermia, just a lucky rock holding the starter kit for biology? Or is it a probe? A machine designed to dust planetary systems with the ingredients for life? The friendly gardener theory suggests this specific chemical wake is a feature, not a bug. And that sunward jet? If you were spraying a field, wouldn't you aim the nozzle? I'm not saying it's aliens, but I am saying that if you engineered a cedar ship, it would look exactly like this hard shell, a stabilized trajectory and a wake of organic compounds left behind. We are watching a celestial crop duster work in our backyard. Then there is the chameleon effect, the colour. 3I Atlas started deep red, the standard colour of interstellar age. As it hit the Sun, it burned emerald green. That happens. But now, as it speeds into the freezing dark, it has turned electric blue. Blue light in astronomy usually signals extreme heat or ionized gases like carbon monoxide. It means high energy. But the object is moving away from the energy source. It should be cooling down to red. Instead, it is powering up. Why? One theory is that the Sun stripped the crust to reveal fresh ice. But the other theory, the one astronomers whisper about, is that the blue glow is the spectral signature of an engine, and while it glows, it drones. The Meerkat radio telescope has locked onto a signal at 1665 megahertz. The scientists say hydroxyl radicals, just water molecules breaking apart. That is the safe answer. But here is the anomaly they bury in the footnotes. The signal is steady. Natural comets sputter, they crackle and fade as they tumble. 3I Atlas is emitting a constant hum, a carrier wave. If it is natural, it is the smoothest venting ever recorded. If it is artificial, that hum is exactly what a system in standby mode sounds like. We are 24 hours from the closest pass. What are we looking for tomorrow? We are looking for the seeds. New analysis suggests the debris trail isn't dust, it is gravel. Heavy pebbles. This is crucial because fine dust blows away. Pebbles stay. They settle into stable orbits. If this object is seeding us, it isn't using a spray, it is dropping heavy capsules that will linger in our system long after the visitor is gone. And we still haven't seen the face of the object. The blue gas cloud acts like a curtain, wrapping the nucleus in a fog thousands of kilometers thick. Is it a shield? A camouflage? Tomorrow the Sun hits it from a new angle. We might finally get a glimpse through the thinning tail. We might see if it's a jagged rock or a smooth cylinder, but the scariest part isn't the noise, it's the silence that comes next. 3I Atlas is not stopping. It is travelling at 30 kilometers per second on a hyperbolic escape path. It crosses Jupiter's orbit in March 2026, and then it is gone forever. It didn't slow down to say hello. And that fits the Scout profile perfectly. When you map a jungle, you don't stop to talk to the ants. You scan the terrain, drop your sensors, and keep moving. Is Atlas the marker? Maybe that sunward spike is an antenna beaming data home. Maybe the seeds are dormant sensors waiting to wake up. We have been visited. Was it a rock, a gardener, or a scout testing our defences? Tomorrow, December 19th, is our last best look. The data we capture in the next 24 hours will be analysed for 50 years. We will look for the gap in the gas. We will listen to the hum. We will analyse that impossible blue light. Do not look away. The universe just rang our doorbell. We need to be awake to answer. Hit subscribe and turn on notifications right now. I will be tracking the flyby minute by minute. If the trajectory shifts, or if that shell finally cracks, you will know it here first. I'll see you tomorrow.